In this video, we shall be solving this problem and we shall be applying a particular law of logarithm that they don't teach in most secondary schools. Now, we are told that 4 raised to the power of x equals 8x, and we have to show that x equals 2. So we have been given the solution already. We have been told that x equals 2. We are required to show a solution steps that will arrive us at x equals 2. All right, let us begin. So we have that 4 raised to the power of x is equal to 8 multiplied by x. Now we know that 4 is same as 2 raised to the power of 2, right? Which is equal to 8 is same as 2 raised to the power of what? 3 multiplied by x now. Now, at this stage, we are going to divide both sides by 2 raised to the power of 3. So dividing both sides by 2 raised to the power of 3, we have 2 raised to the power of 3 here, divided by 2 raised to the power of 3 here. Now, this is going to take on this, and we have that x is going to give us 2 raised to the power of 2x multiplied by 3. Now, this is from division law of indices. When the bases are the same, we have to subtract the powers, right? Now, when most persons are solving this problem, once they get to this stage, they will be stuck at this stage. They won't know what to do anymore. Now, it is at this stage that we are going to apply the law that I am talking about. Now, if you have watched this video to this extent, kindly like the video, subscribe to the channel, and turn on post notification so that you would be among the first to be notified when a new video comes up. All right, recall that if a raised to the power of x is equal to n, then we know that x is equal to what? Log n base a. We all know this, right? We know that if a raised to the power of x is equal to n, then converting it to logarithm, x is going to give us log n base a. So from these two equations, it is equivalent that a raised to the power of log n base a is equal to n. I will explain. Now, from the first equation, we have if a raised to the power of x is equal to n, right? And this is the other equation, which is converting this first one to logarithm form. Now, we have that x equals log n base a, right? Now, this expression for x, which is log n base a, we are going to bring it back into this first equation to take the position of x, which is the power of a, and putting it in the position of x, we have that a raised to the power of x now is now going to give us a raised to the power of log n base a, and it will be equal to the same word n. So this n is this n, and this log n base a is this power here x, because from here we have that what x is equal to what? Log n base a. Now, this is the law. When a parent number is raised to a logarithm power and the base of the log is same as the parent number, then the result of such expression is the number in which the log is expressed. Now, we have a parent number a. It is raised to a power, and the power is a log. It is raised to a power of log n base a. Now, we have seen that the base of this log is same as what? The parent number. Then, if it is in this format, the result of this whole expression is equal to this number n, which the log is being what? Expressed. Now, you may be doubting, but let me show you an example. Let us say we have 3 raised to the power of log 9 base 3, right? Now, according to the law that I just stated, I am saying that the result of this whole expression is 9. How? We know that 9 is what? 3 raised to the power of 2, right? So we have 3 raised to the power of log 3 raised to the power of 2 base 3, right? And from power law of logarithm, this power 2 here, we come and what? Multiply the log. So this is going to give us 3 raised to the power of what? 2 multiplied by what? Log 3 base what? 3. And this is going to give us 3 raised to the power of 2 times log 3 base 3 is what? Is 1. And this is going to give us what? 9. So we have seen that what? The law is true. So going back to our solution, we have that x is equal to what? 2 raised to the power of 2x minus 3. Now the power of x here is 1. Now because I have seen that the parent number in this right hand side is 2, we are going to take logarithm to base 2 of both what? Powers. So take logarithm to base 2 of both powers. So at this left hand side we have what? Log 1 base 2. X is raised to the power of log 1 base 2. And it's going to give us 2 raised to the power of log 2s minus 3 base 2, right? So now, I said take logarithm to base 2 of both powers. The power of x here is 1. So we are taking logarithm to base 2 of what? This power 1. So we have x raised to the power of log 1 base 2. On this right hand side, we have the power as 2x minus 3. So we are taking logarithm to base 2 of this power. So we have log 2s minus 3 base 2. Now from this left hand side, we have seen that the log is the log of 1 to base 2. And we know from the laws of logarithm that logarithm of 1 to any base is 0, right? So on this left hand side, we have x raised to the power of 0 equals, now on this right hand side, we are going to apply this our law that we have established. Now we can see that this is a parent number 2 that is raised to a logarithm power, right? Now the base of this logarithm power is same as the parent number. So it therefore means that the result of this right hand expression is equal to what? 2x minus 3. So x raised to the power of 0 is going to give us 2x minus 3. And x raised to the power of 0 is what? Is 1. It's going to give us 2x minus 3. Now collecting like terms here, we are bringing this negative 3 to this left hand side. It is going to change to what? Plus. So we have that 1 plus 3 is equal to 2x. 4 is equal to what? 2x. Dividing both sides by 2, x is going to be equal to what? 4 over 2, which is equal to 2. Alright, that is the solution. We have that x is equal to 2. So if you enjoyed this video, do not forget to like the video and subscribe to the channel. See you in my next video.